Hi, class. So this is an example pre-exercise, and this is sort of the expectation of what your final assignment is going to look at. The neat thing about do files is you can run commands and sort of type in text and comments interactively. So what I'm doing right now is just gonna add some comments to indicate who wrote this code and when I wrote it. So the author is David Lang. Date written is 9/22/2021. And the data set we're going to be working with in this video is a data set involving smoking, health risk, BMI, and a few other features. And the expectation is this first week, we're not going to be doing a lot of sort of intense, complex statistics. What I really want us to be able to do is feel comfortable loading a data set, looking at it, understanding what it is, and then potentially doing some basic manipulations to understand what's going on and what are some questions of interest. So again, what I'm going to be doing is loading in our data set. And what is really nice about Stata is you can generate something called a log file, which will generate an exact history of every command you run. So for instance, if you're working with really big data, that it takes a long time for things to run, and say you want to look something up, understand what you did. If you save a log file, you won't necessarily need to redo your analysis. And if you save a do file and decide you want to make changes, then you can also just rerun your do file and having to remember exactly how you did and what you did. So I'm going to walk you through line by line of what each function, each code does, and how that's involved in our exploratory data analysis. So the first thing we're going to do is we're going to clear the workspace. That is just getting rid of any data I may have loaded beforehand. And then what I'm going to do is I'm going to close any log files. So if I was recording information in this session, I'm closing it and starting a new log for this week 1 pre-exercise. And the first thing we need to do to understand the smoking data set is we're going to use the web use command, which is just downloading data set that's available off the internet. Okay. And we can see that our data set has been loaded. All right, I'm going to shrink my browser just a bit so you can see everything that's going on, and I'm going to shrink the command line just a smidge as well. So you should have a pretty good sense of everything that's going on screen, and you can see the associated command. I'm going to be sending you this log file. So we've loaded our data set. We can see all of the variables. And what I would like to now do is, and this is something I try and always do, is describe the data set so I know just how big it is. We've got roughly 17,000 observations, 16 variables, and it takes about a megabyte of space. So it's pretty small, but believe it or not, even as of a few years ago, about 10 or so years ago, you were getting pretty close to an Excel limit with this big of a data set. Okay, so what I'm then going to do is I'm going to describe, I describe the data set. What I can then do is I can also print out code that's a function of the commands and things in my data set. There are special commands called lists. And so after you run a command, if you type return list, you get special arguments that will let you know what is in your data in accessible ways so that if you want to write code. So right now, all I'm doing is using this boilerplate code to print out how many variables are in the data set and how many observations there are. This is known as a macro or a reference variable. And you see when we type it out, the command understands what we are looking for. And so the first part of this assignment is describe 2 of the variables. And to do that, what I do is I go to this codebook command, I run it, and I look at what is interesting to me, what do I notice? And things that pop out to me is that we have a serial number variable that typically means that it could be used to identify an individual. We don't necessarily care what the summary statistics are for these sorts of identifiers, but one of the things we do like to make sure is that they're unique. So for instance, there are 17,260 observations in our data. The serial number identifies has 17,260 unique values. And we have no missing data, which is always a nice thing. So that is pretty interesting and necessary for us to do good analysis. And we're going to scroll down, and then we've got this variable that is also of interest called 10-year mortality. And that is what's called a binary variable. It takes on the value of either 0 or 1. And it doesn't explicitly tell me this, but what I think this data represents is if you die within the next 10 years, you're a 1. And if you don't, you're a 0. And we also have a variable called cigarettes, which is just an individual's daily cigarette consumption. We've got their blood pressure, their age, their height, their weight, cholesterol, and a few other variables that we're not going to worry about in this analysis. So one of the things that if we're interested in smoking and mortality, we probably want to understand the cigarette variable a little bit better. The 2 questions I've given you are what is the cigarette variable? So we have this nice little label here, but we can go down and look at it a little more carefully by just writing codebook and sig. We can see that on average, this population smokes roughly 6 or 7 cigarettes per day, but it's a very interesting distribution. That some people smoke hardly at all or none, and some people smoke more than 60 cigarettes a day. And in fact, what we see is that the median user or median individual in our data set smoke 0 cigarettes per week. And so the next thing that we've been asked to identify is how many heavy smokers there are, and we're given a definition of 5 cigarettes or more per week. So we're going to do that. We're going to create a variable called heavy smoker, and that's going to be equal to this sort of conditional statement. And that's going to be cigs greater than 5. All right. And now you notice when we look at our environmental variables, we can see we've got a new one called heavy smoker. And now I want to understand what percentage of our population are heavy smokers. There are a number of different ways we can do this depending on our purpose. A simple way is to use this command called tabulate, or tab for short. And we can do heavy smoker. And we can see that roughly 35% of individuals are smoking. And if we want the exact raw number, we have that available to us here. There are a couple of other ways we could get that information. We could use that codebook command. That is helpful. It lets us know the raw number, but if I wanted to compute a percentage, it doesn't give that to us. We could use a summary command, which is just abbreviated as sum. We could use that, and we get our percentage, but we don't necessarily have our percentiles the way we would like them. So we could also use an extended option, which is when you put an extra comma and a command after. So for instance, detail, summarize. And this is one of those things that you just need to get comfortable with, is you're going to make typos and you're going to make mistakes. And now we have that information and we have the associated percentiles, which in this case, it makes sense that, you know, you're either a 0 or 1, you're either a heavy smoker or you're not. Now, the next question is, for people who smoke, how much do these individuals smoke a day? There are a number of different ways we can go about solving this problem. We could construct a visualization. And so what we'd be asking then is we'd be using this command called go to graphics, histogram, select our variable, and we would choose cigarettes, and we'd need to create a conditional, and that would be heavy smoker equals 1. And we get our plot that way. And we see that there appears to be a pretty big spike at 20, but it's not quite clear what that exact number is. It looks something like 13 or 14%, but we don't necessarily know that. So another way we could look at this is we could use that pad command again. And we can scroll up to 20, and we see, in fact, actually it wasn't 14%, it was actually more like 7.5. And that's one of those things where histograms can be deceptive, is that they have different bin widths and that they can make data look like a lot more or a lot less, depending on what the widths are. So that's one of the ways we can do this analysis. Another I think that's a good approach for now. Another is if, say, we didn't have our sorry, I realized I gave you the wrong analysis. We were asking amongst heavy smokers, clearing the screen, clearing the screen. Okay, take 2. So this data set is asking us how many are heavy smokers. We use the table heavy smoker option. And now I ask you, how many people, of people who don't smoke, of people who do smoke, how many cigarettes do people smoke a day? So we could run the tab cigarettes command, and depending okay, let's try this one more time. We are trying to generate, figure out given that someone smokes, how many cigarettes do they likely smoke per day? And so what that basically means is we're trying to find a statistical mode. And what we can do for that is we can actually sort our data by the numerical value, like we do here, or we could also sort it by on its relative frequency. And the way you just sort of intuit and learn all of these things is that for every command, there's a help file. And so one of the things I always do is just go to a command and sort of read the help file to see what sort of arguments it can take and what sort of options it can generate. So for instance, if I wanted to generate a plot of the relative frequencies of this, I can use this comma plot option. If I wanted to sort the frequencies in descending order, I can use this sort option, or if for various reasons, I only want to look at percentages, I could use this no freq option. And let's explore that a little bit more. So all right, so we see that it seems like 20 is when people, if you're smoking, that seems to be the most likely number that you're smoking, which I guess is a pack a day. I'm not necessarily sure. But say we're finding this a little bit too overwhelming and all we want to know is the percentage. Well, we can use the plot option, and we can get this in line and just get a very clear visual. Another option is we can also sort the data, and then this information becomes readily available. And I think what this does sort of go to show is that very basic decisions make finding and communicating information very quick and very clear, or it can sort of bury information. So taking the time to figure out how to properly communicate things is quite important. Let's go on to the next step. So we're going to generate a variable that's called BMI, which we're using as this formula weight over height. That should be pretty easy to generate. We've got this variable weight, and we've got this variable height, and we're going to call this BMI. Let's see, does this look sort of like what we know a body mass index looks like? No, it doesn't. But normally we know that BMIs tends to range somewhere between like 15 and 40, and that they tend to be pretty normally distributed with a peak at 25. So what did I do wrong here? The generate command worked fine. Oh, I know. I did not actually correctly type out the formula. So what we want to do is replace that. The formula for BMI is actually weight over height squared. Let's take a look at that. Does that look any better? Kind of, but it's clear we're off by a factor of 1,000. So we want BMI to be, let's see. Okay, lowest BMI we have is like 18 hundredths or 18 thousandths of a percent. Highest BMI is like 32 hundredths of a percent. That clearly is off, but I think it's off by an order of 10,000. So what we can then do is actually use this replace command again and do exactly that. And let's take a look at our BMI variable, a mean of 24, a max of 40, and a min of around 14. That looks pretty good. Let's just do a histogram and see if it sort corresponds to our expectations. Yes, it does. It peaks roughly at around 25. It's nice and normally distributed. There aren't any weird outliers. There aren't any values that are 0 or values above 40 or 50, which is exactly what we would expect. And so we are going to plot our BMI for smokers, and we'll see if that looks any different. Well, what we do is actually call this smokers BMI. And honestly, it doesn't look that different to me. Let's take a look. Let's generate a variable called smoker. And that's one of the nice things we can also do in Stata is we can generate summary statistics by groups using this by sort command. So what we can see is that the median non-smoker is actually has a slightly higher BMI than a smoker does. And on average, when we also look at means here and here, we see that smokers are actually a little bit lighter. Maybe that has something to do with gender distribution. Maybe it has something to do with age. We're not going to get into it here, but thinking, does this sort of conform with your expectations is always helpful. And so the next question we have is, do people with a BMI over 30 have a higher probability of dying in the next 10 years? Well, first, let's take a look at that all-10 variable. And we see that, okay, about 10% of people in our data set are likely to die in the next 10 years. Okay, so the question is, do individuals who have a BMI of 30 or more, are they more likely to die? So let's generate that variable. And then we want to do this comparison. Okay, and we see that individuals who have a BMI below 30, they have about a 9.5% chance of dying in the next 10 years. Individuals who have a BMI above 30, they have about a 14% chance of dying. We can actually do statistical significance testing on things like this. So we could and we can actually see that this is also a statistically significant difference. We'll talk more about that later, but I just want you to know this capability exists. And the final question is, do people who smoke heavily, are they more likely to die as well? And we can basically run that same command. We want to run that same command. We've got heavy smoker and non-heavy smoker. And we see that you've got a 7% chance of dying if you're not a heavy smoker, and you're about a 15% chance of dying if you are a heavy smoker. So that also is interesting, informative, and just shows you the power of being able to write these commands. The other thing that is really neat about Stata, in addition to generating commands that are pre-built, you can actually download and install other users' commands. So what I'm doing here is doing something called installing a bin scatter plot. So I'll show you why I'm quite a big fan of this. Is we're going to generate a visualization of the number of cigarettes and whether or not an individual is likely to die. So we're going to create a graph called two-way graph scatter sig all 10. Okay. And it's really hard to see a correlation here because we're only looking at a binary variable that you either die or you don't. What we can do is we can sort of look at all of the folks who have a similar number of cigarette consumption and take the average across that group. And that's exactly what this bin scatter command does. And what I'm going to do is I'm going to model the probability of death as a function of how many cigarettes you consume. And this n quantile command is just letting me know how many points I want to plot. I'm going to do 50. And here we can see that your probability of dying clearly is going up a little bit for each additional cigarette you smoke. Yeah, and I think this is a great jumping off point. Your homework for this weekend is to generate one open-ended unique plot that highlights something you think is interesting in this data set. And there's a exercise that uses the sysuseAuto command, a different data set called sysuseAuto. You'll be using that as well. And the way you can access it is you are going to want to clear your data set, and then you're going to use sysuseAuto describe, or sorry, sysuseAuto clear. And I'm just going to ask you a couple of very basic questions and ask you to make a plot. Thank you so much. I'm really looking forward to our time together. Thank you.